Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I will go and visit the quadratic equation again. Yes, I did that before, but I still see some students are having trouble. And I want to talk about it from the same perspective. I always try to relate different subjects together. So if we are looking at a quadratic equation and we are solving using, say, the quadratic equation formula, I want you also to see that as a parabola, right? We talked about that before. So generally speaking, we say the equation would be ax squared plus bx plus c equals 0, right? So I may have the b may be 0, the c may be 0, but generally I have a, b, and c. And again, this can be represented as a parabola, right? If you plot it, and depending on whether a is positive or negative, this parabola is opening up or opening down. So if a is positive, I will get the parabola looks like that. And then generally, so that you know that before going to Algebra 2, is that we call that the degree of the polynomial. If that degree is even, meaning 2, 4, 6, 100, it doesn't matter, the two branches will either be opening up if what we refer to as the leading coefficient positive, or both of them go down if the leading coefficient is negative. Okay, so the leading coefficient is telling you, is this thing opening up or down? And if that number is even, then both branches will either both go up if the leading coefficient is positive, or both go down if the leading coefficient is negative. If the polynomial degree is odd, we are not going to talk about that. Maybe you'll wait until Algebra 2, and I have, explained that in detail. Now, where did the equation came from? Negative b plus or minus, and you have to memorize it, or you memorize the discriminant as b squared minus 4ac. Where does this come from? It's simply we are completing the square and solving for x. Remember, if these are numbers and you want to solve for x, we talked about that before. We are going to bring the ax squared plus bx on one side and move the constant to the other side. And there are many ways to complete the square. The method I prefer is to take a out and then divide b by 2 and square it, or the x term by 2, in which case it would be 2 over b over twice a and square it. But instead, let's do something different, which is usually what the books or people will tell you. I would say multiply both sides by 4a, and someone would say, why 4a? The reason is I want to make a perfect square. So the first thing I'm going to do, notice what I have here, 4a squared x squared plus 4abx equals negative 4ac. Now, remember, we said if I have the a, that's the square root of a square, I want to have a b. So the only way I get a b is that I add b squared. So that now you see here, the square root of the first is 2ax, the square root of the last is b. When you multiply them, you get 2abx. You multiply that by 2, remember, when you square. So basically, this thing would be 2ax plus b quantity squared. Try to factor, we already factored this, so try to solve for, you say, the first square plus the second square plus twice the first times the second, right? That's how we expand. Equals b squared minus 4ac. Then I'm going to take the square root of both sides. But remember, when you take the square root, you say plus or minus, right? Because the square root of a square here, that would be twice ax plus b. And that becomes plus or minus the square root of the discriminant. And after that, you subtract b from both sides. So you get twice ax equals negative b plus or minus the square root of b squared minus 4ac. And finally, you divide both sides by 2a, twice a, to get the x. And you get the familiar equation. Now, how do I understand that? How do I understand that in terms of the parabola? Very simple. Here, the parabola has a symmetric axis, right? Axis of symmetry. Why do we call it axis of symmetry? We call it axis of symmetry because the right-hand side and the left-hand side are mirror image. Meaning, if I have a point that is, say, 4 units to the right of axis of symmetry, there must exist another one 4 units to the left. That's the plus or minus. So 1 to the right, 1 to the left, 1 to the right, 1 to the left, they are equal. And that's why we have the positive or negative. If you go down along these two branches, you will reach a point where you add or subtract 0, right? It's only a unique point. So this thing would be 0, and you get the famous equation that they told you for a symmetric or axis of symmetry of a parabola is x equals negative b over twice a. It's not magic. It's just substitution, very simple substitution, right? So now that's the vertex. When we do that, this vertex have one of 3 cases. It may be above the x-axis. Notice the solution, meaning the point or points of intersection of the parabola with the x-axis. So if it's above, if this point is above and it's opening up, it will never intersect the x-axis, in which case you will get a discriminant that is less than 0, meaning they are 2 imaginary or 2 complex solutions. A case that may happen is that this vertex is exactly the point, a single point of intersection. So you will get, it's the x-axis will be tangent to that parabola, or it's below the x-axis and opening up, so it intersects at 2 points. So you may have 2 solutions if the vertex is below the x-axis, or above it if it's opening down. If it's opening down like that, and you have it's above the x-axis, you will get 2 solutions. If it's exactly on the x-axis, you get a unique solution. And if it's either below it and it's opening up, or above it if it's opening down, you will never get any solutions. And these are the 3 cases. Okay, so that's why I want you to understand the meaning of getting 2 solutions or a unique solution or no solutions. Let's take some examples here, maybe one of each, so we can see that. Oh, I don't need that. So suppose the first equation, we can make an easy one, like we can say x squared plus 8x plus 16 equals 0. Of course, if you want to use the equation, you can, some of you already saw that as x plus 4 quantity squared, right? But If you don't know it, we can say A equals 1, B equals 8, C equals 16. I'm going to substitute in this equation, and I say x1 and 2, meaning I have two, theoretically, I have two answers. Negative b, so negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 16 over 2 times 1. So it's negative 8 plus or minus square root of 64 minus 4 times 1 is 4 times 16 is 64 over 2 equals negative 4. It's really negative 4 and negative 4. It's negative 4 plus 0 and negative 4 minus 0. So you get basically negative 4 and 0, negative 4 and 0. It's the same point. It's the same point. Just a unique point because the x-axis is a tangent to my parabola. And this will help you also if you figure it out in Algebra 2. In Algebra 2, when you solve polynomials and you get a number that repeats either twice or 4 times or 6 times or any even number of times, you know for sure that this parabola or this graph will not, at this point, will not cross the x-axis. Oh, it touches the x-axis and goes back. But if it's odd, meaning it's a single point, it has to cross it, right? Like if this was the x-axis, it will cross it and then cross it back again, 2 different points. And that's why we say, if the answer repeats, okay? So it has a multiplicity, we call it in Algebra 2. An even multiplicity, it means that polynomial graph will not cross the x-axis. It will touch it, and now you see why. Because when it touches it, I have two answers. The axis of symmetry plus 0 and the axis of symmetry, the x-coordinate of the axis of symmetry minus 0, which is the same point. So it boom, boom, touches and goes back. Okay? Again, this is, you will learn it next time, but you should already understand it, right? And that's the important thing, is not to memorize. Don't say, oh, and they told me when the multiplicity is even, it doesn't cross. No, you have to understand why. There is no magic in math, okay? Just everything should be easy to understand. Now let's have another equation. Negative twice x squared, maybe let's try to see something that plus maybe 20x. Minus 30 equals 0. And someone will say, oh, that's a parabola opening down. Yes, absolutely. Absolutely. But you learned in math that if you have an equation equal to 0, you can simplify. I see that all these numbers are even, so I can divide by 2 and it's the same graph. Someone else would say, oh, I caught you, Mohammed. If I divide by negative 2, that parabola would be opening up, not down. And you were kept telling us, oh, if it's above and below, wouldn't that change things? No. If I divide it by 2, I will get negative x squared plus 10x minus 15 equals 0. And if I divide by negative 2, I will get x squared minus 10x plus 15. Right? Let's see what happens. This one is opening down. Remember, the x coordinate of the axis of symmetry is negative b over twice a. Negative 10 over negative 2 is positive 5, x equals 5. And this one is opening up. but the axis of symmetry is still x equals 5. But let's find the y corresponding to x equals 5. If x equals 5, this would be negative 25 plus 20, that's negative 5, minus 15. Oh, I'm sorry. I said, did I do it in such a way that I will end up with, yeah, it should be fine. Negative 25 plus 50 is positive 25 minus 15 is 10. So this point is 5 and 10, meaning it's above the x-axis, so I will have two answers. What about this one? If x is 5, this is 25 minus 50, that's negative 25, plus 15 is negative 10. So this point is 5 and negative 10 instead of 5 and 10, but it's opening up, so it's below the x-axis, and I will get the same answer. So that's why it doesn't matter if you simplify the equation. Okay, so now if we want to proceed, we are going to say, it doesn't matter. This one is pretty much is easier because the x squared is positive. So when you say a is 1, it doesn't matter. You can do it. You can use either one. You get the same answer. A is 1, B is negative 10, and C is 15. So x1 and 2 would be negative B. B is negative 10, so negative 10 is positive 10, plus or minus the square root of negative 10 square is 100, minus 4 times 1 is 4 times 15 is 60, over twice A over 2. Notice this would be 10 plus or minus the square root of 40 over 2. But square root of 40 is the square root of 4, which is 2, times the square root of 10. So I can write it as 2 root 10. And now I can simplify by 2 again, and I get 5 plus or minus root 10. And these are two answers, meaning it's, if I'm below, I'm going to cross above at 5 plus root 10 and 5 minus root 10. The x-axis, the y-axis would be here. Or here, it's the same thing. This is 5 and 10. I get 5 plus root 10 and 5 minus root 10. And in both cases, I have two answers. Now, the last case where we would have, we want to make the discriminant less than 0. So if I say, for example, x squared plus 3x 9 squares, okay, plus 5 equals 0. And I want to solve that. That's a parabola opening up. The A is 1, the B is 3, and the C is 5. Notice that they always tell you in school, which it's okay. You can find the B squared minus 4AC, which is the discriminant. In this case, it was 0. So we know we have a unique answer, meaning the x-axis would be tangential to my parabola, and the parabola touches and goes back. Okay? So when I graph it, I'm not going to cross the x-axis. I know I'm going to touch it and go back, or touch it and go back. Here, the B squared minus 4AC was 40, was positive, which means we have two answers. And if it's negative, like B squared minus 4AC is 9 minus 20 is negative 11. So we know that either the vertex is above the x-axis and my parabola is opening up, or it's below the x-axis, but my parabola is opening down. So it will never intersect except in the complex world, in the complex universe, okay? And you will learn more about complex numbers and dealing with them later. Okay, so if I want, I already know that this is negative 11, so there is no reason to do it again. I can say x equals negative 3 plus or minus the square root of negative 11, because we already did b squared minus 4ac, There is no reason to repeat it, over twice a. So it would be -3 plus or minus the square root of 11i, or I times the square root of 11 over 2. And that's an imaginary solution. Okay? So please always try to understand, to learn, not to memorize. Don't memorize that when b squared minus 4ac is positive, I have two roots. If it's 0, I have one. You have to understand why. Why 2, why 1, and how you plot that. And why do we say that the x coordinate of the vertex is -b over twice a? Well, it comes from this quadratic equation. When you go down or up until they intersect, they will always intersect at the axis of symmetry, of course, right? Makes sense, right? It cannot intersect somewhere else at a point. So that point is -b over twice a. If you are here, you add and subtract the same quantity. Why the same quantity? Because that's the meaning of axis of symmetry, right? The right branch and the left branch, if I close this paper or apply it, they will coincide. Of course, they're not drawn to scale, so don't make fun of me, okay? But if they were drawn to scale, they will exactly intersect one over the other. Okay? Alrighty. So again, if you have any questions, don't hesitate to leave me a note or a comment, and I will get back to you as soon as I can. Thank you very much for your time. Hope to see you soon. Bye.